All right, so I'm going to do the 4 examples from our momentum and impulse notes that we took on Friday. Our first example says a 20-kilogram child is riding a 5-kilogram bike with a velocity of 4 meters per second to the northwest. What is the momentum of the child and the bike? Okay, so it is asking me right off the bat, what is the momentum of the child and the bike? So it's not just asking me for the momentum of the child or the momentum of the bike, it's asking for the momentum of the child and the bike. So in order to know the momentum of the child and the bike, I need to know the mass of the child and the bike combined. So I'll be looking for that here in a second. So momentum is what I need to solve for. All right, so momentum is symbolized with the letter P. So momentum is unknown. Then referring back to mass, I have the mass of the child and the mass of the bike. So combined, they are 25 kilograms. So just to show you here, the mass is 20 kilograms, that's the child, plus 5 kilograms of the bike. When I add those together, I get 25 kilograms. So the total mass is 25 kilograms. And it also says that they have a velocity of 4 meters per second. So that is my velocity. So V equals 4 meters per second. Okay, well, my equation says that momentum is equal to mass times velocity. So if I plug that into my equation, momentum is unknown. The mass, we determine the mass of the child and the bike is 25, and the velocity of them together is 4. And it comes down to multiplying 25 times 4, and when I do that, I get a momentum of 100. Units are kilograms, that's a K by the way, times meters per second. 100 kilograms times meters per second. All right, so we're going to skip the example number 2 that is in your notes. We'll come back, and our very first example was solving for momentum. Sometime when we're talking about collisions. The next example I want to look at is example number 3, and it's referring to a 0.5 kilogram football thrown with a velocity of 10 meters per second to the right. A receiver catches the ball, bringing it to rest in 0.10 seconds. What is the force exerted to stop the ball? Okay, so let's see here. The last sentence says, what is the force? Which means that force is unknown. So force is what I want to solve for. Okay, let's see. It says that it's got a 0.5 kilogram football. So that tells me the mass of the football is 0.5 kilograms. It tells me it's got a thrown with a velocity of 10 meters per second to the right. Okay, so it's telling me that it's initially being thrown at 10 meters per second. So my initial velocity is 10. And if the receiver is catching the ball and bringing it to rest, then that's telling me that the football is coming to a stop. That means its velocity is stopping, so its final velocity is 0. And the last thing that it shows me in here is 0.10 seconds. That is time. So my time is 0.10 seconds. Okay, well, what this basically says is that there is a force that is occurring over a certain amount of time, and it's causing a change in velocity, therefore a change in momentum. So Ft equals m times Vf minus Vi. Well, force is what I need to solve for, so I'm going to rewrite it as F. Time is given to me. It is 0.10 seconds. Mass of the football is 0.5. Vf is 0. Vi is 10. Okay, well, 0 minus 10 is a negative 10, and a negative 10 times a 0.5, that gives me a negative 5. So when I multiply a negative 10 times 0.5 in my calculator, that gives me negative 5. And on the left, I have f times 0.10 still. Well, if I'm looking at this, I've got f times 0.10. I want to get this to the other side so that f is all by itself. So the opposite of multiply by 0.10 is to divide by 0.10. So I'm going to divide by 0.10 on both sides. And when I do that, these cancel out, and that gives me f all by itself. And I have a negative 5 divided by 0.10, and that gives me a force of negative 50. So in other words, the football is moving to the right. When the receiver catches it in his hands, the receiver's hands apply a force that is directed to the left, against or opposite the direction of the force of the football. On the one before that, we solve for force. Example number 4 says, what is the mass of a ball that's hit with a force of 15 newtons and travels from rest to 12 meters per second in 2 seconds? Okay, so first sentence here says that the mass is unknown. So I need to solve for m. It says it's hit with a force of 15 newtons. So that is F. It travels from rest to 12 meters per second. So it's starting off stationary. So its velocity when it starts has to be 0. And then it's moving. Its final velocity is 12 meters per second. And lastly, it tells me 2 seconds. So the time it takes to do all that is 2 seconds. Okay, so again, it's telling me that there is a force that is occurring over time that's causing a change in velocity, which is a change in momentum. So F times T equals M times VF minus VI. So let's substitute. For F, I know it is 15. My time was 2. The mass of the football, the mass of the ball is unknown. That's M. Final velocity was 12 minus the initial velocity, which was 0 because it was at rest. Okay, so let's start with the left side of the equation. I can do this. 15 times 2, that is easy. That gives me 30. And then on the right, I've got M times 12 minus 0. Well, I know 12 minus 0 is 12. And it's still being multiplied by M, so I'm going to write it by, M times 12 minus 0, which is 12. Okay, so I want to get M by itself, but it's being divided by, multiplied by 12. Well, the opposite of multiplied by 12 is to divide by 12. And if I divide both sides by 12, then I get M by itself. And M is equal to 2.5. 30 divided by 12 gives me a mass of 2.5 kilograms. In the previous example, we are solving for mass. In the last one, I have a 0.5 kilogram object that is at rest. A 3 Newton force to the right acts on the object during a time interval of 1.5 seconds. What is the velocity of the object at the end of the interval? Okay, so I am given this information that tells me it's measured in kilograms. It tells me the mass of the object. So I know M is 0.5. It's at rest. So that tells me that it's starting off initially at 0. It's not moving. Okay. It tells me that there is a 3 Newton force. So it's going to tell me F, and I'm going to leave some space because if I'm trying to solve, or if I'm given VI, chances are there's VF somewhere in here. So F is 3 newtons, okay, to the right, so that's a positive direction. That's acting on the object with a time interval of 1.5 seconds. That is my time. Okay, and the last question says, what is the velocity of the object at the end of the interval? Okay, so it's telling me that it's starting off at rest. I want to know how fast it's going at the end of the 1.5 seconds. So that means I'm solving for VF. So VF is unknown. Okay, so just like before, I have a force that is being applied over a certain amount of time, and that is equal to the mass of the object times its change in velocity. So that force is causing a change in velocity, which leads to a change in momentum, which is our impulse, basically. So let's plug in what we know. I know F is 3. The time interval is 1.5. The mass is 0.5. Final velocity we don't know, and initial velocity is 0. Okay, so let's start here on the left. I could do this, 3 times 1.5. When I multiply 3 by 1.5, I get 4.5. So I've got 4.5 here on the left. And then on the right, I've got 0.5 times VF minus 0. Well, VF minus 0 is just VF. I'm not taking anything away from VF, so it's not changing. So I'm just going to rewrite it as is. 0.5. And then VF minus 0 is just VF. Now VF is being multiplied by 0.5. I want to get VF by itself, so the opposite is to divide by 0.5. So I'm going to divide this side by 0.5. I'm going to divide this side by 0.5. So these cancel. And I've got VF all by itself, which is what I wanted. And on the left, I have 4.5 divided by 0.5, and that gives me 9. So the final velocity here is 9 meters per second. So we did an example here showing us how to calculate for final velocity.